Based on the velocity chart of the last 6 iterations, how many iterations do you estimate for finishing 100 story points of work? A little bit of calculation and some understanding of Agile is needed. Yeah. Okay, so I just read the options. It can't be calculated based on what data you see on the board. 3 to 4 iterations, 4 to 5, 5 to 6. It's all about once you calculate, you know the answer. So I pause for a while and then we look at what is possible here. Okay, so what is velocity and how it helps us in calculating the number of iterations in the release? So you can say that velocity represents the quantum of work a team can mark done in a given iteration. So can we read that from this particular bar chart? Now, what is presented here, you see different bars. You see an iteration in the bottom, and the bar has a number written, and the length of the bar is representing the velocity observed in a given iteration. So first thing is that we should be comfortable with reading such kind of graph. So I can see that, yeah, there were different velocities. Now you might say, oh, I know if I have 100 points of work done, I can divide by velocity and find out how many iterations probably this particular thing will need. But here you don't have a given velocity, you have a chart. So which particular I should use in order to calculate the number of iterations needed? Now, in general, we use something which is more recent. Now, if I see here trend, if I take the whole average, it may comes around 22, 23, something like that, if I sum total all. But is it relevant to refer something which was happening in the first or second iteration, where we can say that clearly from the recent 3 iteration, if I take that average, this is something, a trend which I can particularly focus on. So many times we use the recent numbers and take moving average out of that recent number to calculate, predict, or estimate rather than say, to estimate the future velocities. So here I should focus on the last 3 iterations more than the previous 3. Yeah, so I focus on 20, 25, 30. Now, if I take an average, it comes around 25. The pessimistic estimate could be 20 because out of last 3, the 20 was the slowest one and 30 was the fastest one. So if I go the fast speed, still I need 3 plus iterations. I can't finish it in just 3. And if I go slow, I need 5 iterations because 100 divided by 20. And on average, also, I should take around 4 to 5 iterations. And that's why the option C wins here, because I can say that my pessimistic could be 20, my optimistic could be 30, and most likely I will be somewhere around 25. And looking at that, I can say 4 to 5 iterations are good enough. Yeah. So pessimistic will go towards the 5, optimistic probably could be 3.5 or something, but we better focus on the easy number, which is 4. So out of the available option, in such kind of question, the available option also matters. In this particular case, we had a range, so it was easy to select. In some cases, you may end up facing just a one number, but still you need to use your judgment, take the recent observation and focus more on relying on the recent data rather than the past data. And this is how I can calculate the number of iterations needed for the given amount of work. So simply 100 divided by velocity tells me the number of iterations. That's something I'm looking for. But the only thing is velocity I'm using from here. And that's why I'm saying, okay, if I go on average, it will be 25, then it's a 4. If I go little slow in a 20 speed, it could be 20, then it will be 5. Then 4 to 5 is a good option to select given the data I see in the chart.